This video is going to cover Unit 26, Section 2, Areas of Parallelograms. Now, what a parallelogram is when you have a figure where opposite sides are equal and also opposite sides are parallel. Okay? That is a parallelogram. Now, the height of a parallelogram will be from one base to the other, perpendicular. So for example, on this parallelogram right here, the height could be, if I draw a line, now this line right here is not, this angle right here is not a 90-degree angle. So I need to say, like that, if that distance is perpendicular, then the base is going to be this distance from here to here, and the height is going to be this distance from here to here. Now there's another way we can look at that. If I can use this line as the base right here, and then I can draw a line perpendicular. That might not be perfect, but you get the idea here. I can either use this as the base, or I could use this as the base. And then the height is just going to have to be perpendicular to that base to the other parallel line on the other side. So the area for a parallelogram is equal to the base times the height, which is very similar to length times width. All right, so let's take a look at an example of that. Let's see here, right there. At the bottom of page 660, this looks like a good one right here. So let's take a look at that. Let's zoom in a bit. All of my pages are coming out of my book now, so I just use that to my advantage. All right. So we have to, the idea here is we're going to find the area of this figure right here. Well, they've already drawn in this auxiliary line right here. Okay. Now, up above, a little bit above halfway, there's another picture of this same figure, but it's got different things on it. It's got this angle right here as being 47 degrees, and this angle right here as being 47 degrees. Now, the reason why they have those there is to show you that this side and this side are parallel to each other. All right? And they also have the distance from here to here as 6 inches, and the distance, they give it here again, from here down to here is 6 inches. So because this distance and this distance are the same, this line here and this line here are parallel. So if this line is parallel to that one, and this line is parallel to that one, that makes this bottom part of the figure a parallelogram. The top part of the figure is a rectangle. So to find the area of this entire thing, I take 14 times 4. That is the area of this rectangle right there. And then I will add that to the base is going to be 30 times the height of that will be 6. So the whole area of that figure is 14 times 4 plus 30 times 6. So the whole area is 236. All right, so First we had to look at this picture right here, and they're proving to us that it's a parallelogram with this angle right here being 47 and that angle being 47. So that tells me that both of these sides come down at the same angle, so they're parallel to each other. So that right there helps me understand that that is a parallelogram. I can't just show it to you like this right here and make you assume that it's a parallelogram unless they specifically tell you it is. They did not specifically tell us it is. They just told us that this angle right here is 47 and this is 47. And in that tells us that it is a parallelogram. So let's take a look at page number 663 at the very top. Okay? I wrote that right in the middle. All right, so what we have there is figure 26-22. Couple of things we need to know here is that segment AB is parallel to segment CD. That means anywhere along between those two lines, we have the same distance. Okay, so we have two parallelograms there. And also another thing that they tell us is that the length of E is equal to the length of F. These two parallelograms look very different. One is more stretched out and leaning than the other one, but the areas of both of them would be the same because the base of one is F and of the other one is E. And they tell us that E and F are the same thing. And they clearly have the same height because they're between the two parallel lines. So the area of both of those parallelograms is the same. All right? Even though it might not appear to be that way. Sometimes in math, things appear to be one way, but they're not. Now I want to look at number 25. With figure 26-23. So what we have, let me get a ruler here. Oh, wow. My Sharpie doesn't always write very well the first line. Okay. So I'm just looking at a side view of this thing because I can't draw three-dimensional. I'm really bad at that. Unless I have a good drafting board. Okay, now I've got a short distance here. There. All right, so the distance here, can you see that? Let's zoom in a little bit. The distance here is 14 centimeters. I'm not going to write the units. The distance from here to here is 26. And then the distance from here to here they give us as 35. 35. Okay, so part of this is understanding what information you do not need. I don't need to know that that's 35 because it's got nothing to do with this figure because I don't have the parallelogram only goes from here to here. It doesn't take up this whole 35. But the base on this one is 14 and the height would be 26. All right? So this is not, the distance from here to here is not 26. Okay? So we cannot use this 26 as the base. So we can't say We can't use this as the base and then use 14 as the height, because there's angles here. And we know from the Pythagorean theorem that if this were a triangle, let me put that as a triangle, a right triangle. If this were 26 from here to here, this clearly is not 26 from here to here. I'd have to know this distance and then I could calculate it. But so the idea here is that I cannot use 26, I can't use this side as the base because I don't know what it is. It's not 26. I can use this as the base right here. Now the height comes from the distance from here to here, which is 26. So this parallelogram is, the area is 26 times 14. So 26 times 14 is 364. So the whole area in here is 364. All right, let's take a look at page 664 at the very top. We have a figure that looks like this. Okay, so there was an edit point right there. I wanted to do this problem, but I wanted to take some time to set it up. Okay, so what we have here is we have to figure out what the area of this figure is. So we've got to take pieces of it. We've got to draw auxiliary lines just like we've been doing. All right, so how do we break this piece up? So that part right there kind of sticks out. So let's take a look at that. Well, that angle right there is 28 and that angle right there is 28. So that tells me that this line and this line are parallel. So maybe there's a parallelogram in here somewhere. Well, let's take a look at it. Well, this line and this line don't match up at all. So in order for me to have a base down here, I would have to have it come down into here somewhere and then meet up with that. So that's where that parallelogram would have to be. That really doesn't line up very well. All right, but let's take a look at something else that we've got here. This angle right here is also 28. So that tells me that this side and this side are parallel. Okay, I also have numbers down here. So from here to here is 20. From here to here is 20. So that means that if I draw an auxiliary line across right here, now it's not perfect, this line and this line would be parallel to each other because I've got 20 and 20 right there. Well, that means that because this line and this line are parallel, this line and this line would be parallel. So now if I just take this line right here and I extend it, I have a parallelogram right here. So this line and this line are parallel with each other because of the 28 degrees. So that makes this line right here, or this a parallelogram. I have another parallelogram right here because I already know that this line and this line are parallel with each other. So there's another parallelogram right here. Well, let's figure some of these distances out now. So I don't know if you heard that. That was awful loud. Okay, so I can figure this rectangle out pretty quickly. I've got 62 here and 20 here. So that distance would be, I should be able to do that in my head. You got to multiply, not add. 62 times 20. So 1240 for this part right here so far. Now let's take a look at this parallelogram. So what is the distance from here to here? The bases. So that base right there is 62. Okay? So what about the height from here to here? Well, the height from here to here is 43. Now, can you see that? 43. So the distance from there to there is 43. Well, the distance from here to here would be 43 minus 20. So this distance right there is going to be 23. So now this parallelogram right here, the area of that is 62 times 23. So 62 times 23 is 1426. So there's another area. One last area is right here. One thing I forgot to put up here, yeah, the distance from here to here is 17. Ignore this stuff. So that distance right there is 17. So if this is the base right here at 17, I need to find the height right there. So how do I find that height? Well, let's take a look at the two ends here. So from here all the way up to here is 56. From here down to here is 43. Okay, so the distance from here to here is 43, and that's the same distance from here to here. So 56 minus 43 is 13. So this height in here, I'll draw it out here just to keep it from getting too complicated inside of there. So that height from there to there is 13. So that means the area of this parallelogram right here is 17 times 13. 221. So 221 plus 1426 plus 1240 is equal to 2887. So this is the area, and of course, see, what was the units on that? Centimeters squared. So that's the area of the entire thing. Now, a lot of auxiliary lines on this one, and the way I looked at it at first was I was trying to make a parallelogram here, coming down here and meeting up with that. Well, if I did that, oop, that doesn't even look right. It would have to be over to here. And you see, I got all this little area in here that there's no way to figure out what that area would be. Wow, I can't believe I did that wrong. But see, that would be more complicated. So the idea of using this parallelogram right there, and I have to have that angle in order to be able to do that, because I have to know that this side and this side are parallel to each other. If I don't know that, or if I can't prove that in some way, then I can't prove that this would be a parallelogram in there. But because they give me that this angle is 28 and this angle is 28, both of them coming down from perpendicular lines, so therefore I know that this side and that side are parallel. That allows me to make sure that this is a parallelogram in there. Once you have this parallelogram drawn in here, this one right here becomes more obvious. And of course, then this rectangle down here becomes very obvious as well. So then I can just figure out what the areas of each of those three things are and add them up.